The laws of physics seem solid until you venture beyond our familiar world where time twists, space contorts, and reality itself unravels into impossibilities. What if everything you thought you knew about the universe was just the tip of a cosmic iceberg? Hidden in the depths of space are phenomena so bizarre, they make science fiction look tame. Black holes that erase time, ghostly voids where galaxies vanish without a trace, and ripples in the fabric of reality itself. Today, we're uncovering 40 of these mind-bending space-time anomalies, each one defying logic, bending the rules of existence, and leaving even the brightest scientists utterly speechless. This isn't just a tour of the cosmos, it's a front-row seat to the universe's greatest mysteries, ready to have your perception of reality turned inside out. Let's begin. At the heart of every black hole lies a riddle so profound it shakes the very foundations of physics. Picture this: a star collapses, vanishing into an inky abyss where gravity is so strong, not even light can escape. But here's where things get strange. According to Einstein's theory, all the information about what fell in every atom, every particle should be trapped inside forever. Yet quantum mechanics, the rulebook of the tiny, insists information can never truly disappear. This is the black hole information paradox, and it's been haunting scientists for decades. Stephen Hawking famously argued that black holes slowly evaporate, radiating away their energy until nothing remains. But if that's true, where does the information go? Some theorize it's encoded on the event horizon like a cosmic fingerprint, a concept called the holographic principle. Others suggest fiery walls of energy or firewalls might burn up anything crossing the boundary. But the truth, we're still searching. This isn't just about black holes, it's about whether the universe itself keeps perfect records or if some secrets are truly lost forever. And that's a mystery that could rewrite everything we know about reality. The silence of the universe might be the most deafening mystery of all. Look up on a clear night, and those countless stars aren't just dots of light. Each one could host entire civilizations. The numbers alone seem to promise company. With hundreds of billions of galaxies, trillions of planets, the cosmos should practically hum with alien activity. So where is everyone? This is the Fermi Paradox, a puzzle so unsettling it makes even the most optimistic scientist pause. Enrico Fermi, the legendary physicist, first posed the question over lunch in 1950. If life is common, why haven't we found a single radio signal, a distant megastructure, or even a cosmic hello? The possibilities lurking behind this silence range from sobering to spine-chilling. Maybe life is incredibly rare, snuffed out by some great filter, a catastrophic event like runaway climate change or self-destructive technology that wipes out civilizations before they can spread. Or perhaps intelligence is a fluke and Earth is an accidental oasis in a sterile desert. But there are darker theories too, that advanced species avoid detection on purpose, hiding from something we can't yet comprehend. Worse still, maybe we're the first, destined to inherit an empty universe. Whatever the answer, this paradox forces us to confront an existential question. Are we cosmically special or just tragically early? One thing's certain: the stars hold more secrets than we ever imagined. Deep in the cosmos, something unseen is pulling entire galaxies toward an invisible horizon, and it shouldn't exist. Astronomers call this enigma dark flow, and it defies everything we know about cosmic motion. Picture hundreds of galaxy clusters, each weighing trillions of suns, racing in the same direction at blistering speeds, like leaves caught in a hidden river current. The strangest part, there's no visible source for this immense tug. No supercluster, no dense knot of matter, nothing our telescopes can detect. This motion points towards something beyond the edge of the observable universe, a gravitational phantom so powerful it bends the rules of cosmology. Some theorists whisper about parallel universes, that our cosmos might be one bubble among countless others in an infinite multiverse, each with its own physical laws. Perhaps these neighboring realms exert gravitational pull on us, warping space-time from dimensions we can't perceive. Others argue it's a crack in our models, a sign we've misunderstood dark energy or the Big Bang's aftermath. But one thing is certain, dark flow hints that the universe holds cards it hasn't shown us yet. Whether it's a flaw in our equations or a window into something grander, this mystery reminds us that the cosmos still has secrets written in invisible ink. Somewhere in the depths of space, an invisible force is dragging our entire galaxy along with hundreds of others toward a point we can't even see. Meet the Great Attractor, a gravitational mystery so powerful it bends the paths of galaxies like cosmic puppet strings. Imagine the Milky Way, Andromeda, and countless others all drifting toward an unseen destination, as if caught in the slow current of an intergalactic river. What's pulling us? That's the problem. We can't get a clear look. This enigmatic behemoth lurks behind what astronomers call the zone of avoidance, a thick band of dust and stars at the center of our own galaxy that blocks our view like a cosmic blindfold. Early observations suggested it might be a supercluster, a dense knot of galaxies generating immense gravity, but measurements reveal something even stranger. The pull is far stronger than visible matter can explain. That's led some scientists to suspect dark matter, the universe's invisible scaffolding, might be concentrated there in ways we don't yet understand. Others wonder if it's not one single structure, but a chain of massive objects working together in a cosmic tug of war. Whatever it is, the Great Attractor throws a spotlight on just how much of the universe remains hidden from our instruments. Think about it. Our own galaxy's dust obscures a force influencing millions of light-years of space. It's humbling, really. Every time we think we've mapped the cosmos, anomalies like this whisper that we've barely scratched the surface. The Great Attractor isn't just a destination, it's a reminder that the universe loves keeping secrets, and right now it's daring us to look deeper. Imagine two particles born together in a quantum embrace, then flung to opposite ends of the universe. Change one, spin it, nudge it, alter its state, and its twin instantly mirrors that change, as if space and time between them don't exist. This isn't science fiction. It's quantum entanglement, a phenomenon so bizarre even Einstein dismissed it as spooky action at a distance. Yet decades of experiments, from laboratories on Earth to satellites in orbit, prove it's real. No signal travels between these particles, no hidden wires, they just know. So what's really happening? One theory suggests entangled particles aren't separate at all, but connected through higher dimensions like threads passing through the folds of a cosmic fabric we can't see. Others propose that space-time itself might emerge from a deeper layer of quantum links, meaning what we perceive as distance is just an illusion, the wildest implication. Entanglement might stitch the universe together into a single, unbroken whole where separation is just a trick of perception. Think about that. Every particle in your body, every star in the sky, potentially tied together in a vast, invisible web. It's a humbling thought, one that makes borders, even between past and future, feel fragile. Because in the quantum realm, cause and effect don't always play by the rules. Some experiments even hint that future measurements might influence the past, twisting causality into knots. Yet for all its mystery, entanglement isn't just a cosmic quirk. It's the backbone of quantum computing and might one day revolutionize communication. But beyond the tech, it whispers something profound. The universe thrives on connection. Whether through hidden dimensions or threads of pure information, reality is far more intimate, more alive than we ever suspected. And that changes everything. One summer night in 1977, a radio telescope in Ohio picked up something that shouldn't have existed. For exactly 72 seconds, a burst of radio waves screamed across the cosmos, so powerful, so precise that the astronomer who discovered it scrawled, "Wow." In red ink on the printout, decades later, we still don't know what caused it. The signal came from the direction of Sagittarius, but scans of that region revealed nothing. No star, no nebula, no natural cosmic phenomenon that could explain such a focused, intense transmission. Here's what makes it eerie. The signal hit a frequency of 1420 MHz, a radio band where natural cosmic noise is almost non-existent. It's also the same frequency hydrogen, the most common element in the universe, emits. Coincidence, or was it chosen deliberately? A universal hello, easily recognized by any civilization. The more you examine it, the harder it is to dismiss. The signal's strength rose and fell exactly as you'd expect if it came from a distant source passing through a telescope's field of view. Yet after those 72 seconds of silence, some argue it was a rogue comet, a glitch, or an Earth-based signal bouncing off space debris, but none of these explain its bizarre properties. Others whisper darker possibilities, that we caught a fragment of an alien broadcast, or even an automated beacon, before it switched off or moved beyond our detection. The real frustration, we might never know. Despite countless searches, the wow signal never repeated. It's as if the universe teased us with a single, indecipherable clue before slamming the door shut. So was it a fluke, a message, or something else entirely? Whatever the truth, it's a reminder space isn't just vast, it's listening, and sometimes it talks back. Even our most reliable spacecraft can become cosmic mystery machines. Take Pioneer 10 and 11, two robotic explorers launched in the early 1970s to study Jupiter, Saturn, and beyond. For decades, they sailed through the solar system as planned, until scientists noticed something impossible. Both probes were slowing down, not from gravity or friction, but by a force no one could explain. This tiny deceleration, smaller than a mosquito's push, defied every calculation. At first, physicists scrambled. Could unseen clouds of dark matter be tugging at the probes? Was Einstein's theory of gravity incomplete in the outer solar system? The strangest part, this anomaly only affected the Pioneer's other spacecraft, like Voyager, raced ahead unaffected. Years later, researchers found a clue: heat. The probe's nuclear power sources warmed their surfaces unevenly, radiating energy like microscopic thrusters, pushing them backward. Case closed, not quite. While thermal radiation explained most of the slowdown, some measurements stubbornly resisted the answer. For a fleeting moment, we'd brushed against something profound, a hint that our understanding of physics might have cracks. The pioneers taught us humility. Even in our own cosmic neighborhood, the simplest glitch can unravel decades of certainty. And that's the real lesson. Space isn't just about grand discoveries. Sometimes the universe whispers its secrets in the tiniest anomalies, if we're patient enough to listen. The universe is supposed to be an endless, directionless expanse, no up, no down, no cosmic left or right. But what if we're wrong? Hidden in the faint glow of the Big Bang's echo lies a pattern so unsettling. Scientists dubbed it the axis of evil. This story starts with the cosmic microwave background, the oldest light in existence, a snapshot of the infant universe just 380,000 years after the Big Bang. For decades, we've assumed this radiation should be evenly speckled, like static on an old TV screen. But when satellites like Oumuamua and Planck mapped it with razor-sharp precision, they revealed something impossible, a strange alignment, as if the universe had a subtle fingerprint pointing in one specific direction. Here's why it's so disturbing. The cosmological principle, the bedrock of modern physics, declares the universe must look the same everywhere, no matter where you stand. No special places, no preferred axes, yet the axis of evil defies that. It's as if the cosmos whispered, there is a north, and every galaxy, every void might somehow be oriented toward it. Some researchers dismiss it as a statistical hiccup, a trick of measurement, but the odds less than 1 in 10,000. Others dare to ask bigger questions. Could our universe have collided with another in the multiverse, imprinting this odd directionality? Or does it hint at an even stranger truth, that space-time itself has a hidden structure we've yet to uncover? The name Axis of Evil isn't just dramatic flair. It's a nod to how thoroughly this anomaly threatens our understanding. Because if the universe does have a preferred direction, it means we're not just floating in a vast, uniform ocean. We might be part of something far more intricate, something with rules we haven't even begun to decode. And that realization, it doesn't just change the map of the cosmos. It rewrites the compass. Step right up to the most mind-bending toll booth in the universe, the edge of a black hole, where gravity doesn't just bend space, it steals time. Picture an astronaut daring to approach the event horizon, her clock ticking normally as she falls inward. But from our safe vantage point far away, something impossible unfolds. Her descent slows, then stops. Her image freezes, stretched and reddened, as if the universe itself hit pause. Yet she feels no change, plunging toward oblivion, unaware that, to us, she's become a ghostly statue pinned to the edge of forever. This isn't science fiction, it's Einstein's prediction in action. Time warped by gravity so extreme, seconds crawl like centuries. The closer you get to a black hole's maw, the deeper you sink into this temporal tar pit. A single orbit around Sagittarius A, the Milky Way's supermassive black hole, would cost you years back on Earth. Miss a family reunion down here. By the time you return, civilizations might rise and fall. But the real kicker, both perspectives are right. For the doomed astronaut, time flows unbroken right up until, well, physics gets fuzzy. For distant watchers, she never crosses the horizon. Ever, her fate splits into two equally valid realities, forcing us to ask, does time end at a black hole or just fold? Some theories suggest her frozen image encodes all the information she carried, like a cosmic hologram. Others whisper that black holes are time machines, their interiors stitching together alternate histories. One thing's certain, these gravitational monsters don't just trap matter. They twist the very fabric of cause and effect, leaving us with a haunting question. When time itself can be stretched, shattered, or rewritten, what does reality really mean? In the vast cosmic web where galaxies cluster like bustling cities, there exists a desert so vast it defies logic, the Boötes Void. Stretching 330 million light-years across, this eerie emptiness holds only a handful of galaxies where thousands should thrive. It's as if some unseen hand reached into the universe and scooped out a sphere of stars, leaving behind a silence so profound it echoes across space-time. The numbers alone are dizzying. A region that size should contain around 2,000 galaxies. Instead, scans reveal fewer than 60 scattered like lonely islands in an endless ocean. So what carved this cosmic hole? One theory suggests a collision between universes in the multiverse, a titanic smash that sent matter recoiling like droplets from a splash. Others propose something even stranger, that advanced civilizations far beyond our comprehension might have harnessed entire galaxies, dismantling stars for energy on a scale we can't fathom. But the most unsettling possibility, the void might be a flaw in our cosmic blueprint. The standard model predicts matter should spread relatively evenly, like dough rising in an oven. Yet the Boötes Void mocks that assumption, forcing us to question whether dark energy, or something even more exotic, is puppeteering the universe's structure from the shadows. Here's the real twist. Voids themselves aren't rare, but one this size, statistically, it shouldn't exist. Yet there it sits, a cosmic blank spot daring us to solve its riddle. Whether it's a relic of ancient chaos, proof of alien engineering, or a crack in our theories, one thing's certain: the universe doesn't play by the rules we write. And that's what makes the Boötes Void not just a mystery, but a mirror. Stare into its emptiness long enough, and you might just see how much we still don't understand. Just beyond Pluto's frozen realm lies a cosmic boundary that shouldn't exist, a cliffhanger in our own solar system. Picture the Kuiper Belt, a sprawling junkyard of icy debris left over from the birth of the planets. For billions of years, these frozen chunks, some no bigger than a city block, others rivaling dwarf planets, have orbited in a predictable, ever-thinning haze. Then suddenly, at around 50 times Earth's distance from the Sun, the belt ends, not with a gradual fade but a sharp cutoff, as if someone drew a line in the cosmic sand. Astronomers call it the Kuiper Cliff, and its existence throws our understanding of the solar system's history into chaos. So what's lurking out there? One tantalizing theory points to Planet 9, a hypothetical giant world 10 times heavier than Earth, whose gravitational pull might have shepherded these objects inward, leaving a void beyond its orbit. Others suggest a more violent past. A rogue star or passing galaxy could have yanked debris away in ancient times. But here's the puzzle: no evidence of such an encounter exists in the orbits of the remaining Kuiper Belt objects. The real intrigue: this isn't just about missing rocks. The Kuiper Cliff hints at scars from our solar system's adolescence, a time when planets jockeyed for position, flinging debris into the abyss. Maybe the answer isn't a single culprit, but a cascade of forgotten events. Every probe we send, every telescope we point outward, peels back another layer of this mystery, one that reminds us, even in our celestial backyard, the universe keeps its deepest secrets just out of reach. And that's what makes the Kuiper Cliff more than an anomaly. It's a silent invitation to keep exploring, because the next great discovery might be hiding just beyond the edge of what we know. Somewhere in the cosmic tapestry, there's a patch of sky that doesn't belong. Nestled within the constellation Eridanus, a sprawling void stretches over 1 billion light-years, an abyss so vast and empty, it's actually colder than the rest of the universe. This isn't just a quiet corner of space. It's a blistering contradiction to everything we know about the Big Bang's afterglow. Scientists first spotted this anomaly in the cosmic microwave background, the faint whisper of light left over from the universe's fiery birth. Normally, this glow is nearly uniform, like the gentle hum of a refrigerator, but the Eridanus Supervoid, it's a chilling silence in that hum, a dip in temperature so sharp it should be impossible. The numbers don't add up. For a region that size to be that cold, it would need to be unreasonably empty, missing not just galaxies, but even the invisible dark matter that usually fills the gaps. So what carved this cosmic freezer? One radical theory suggests a bruise from a collision with another universe, an echo of multiversal traffic crashing into our own. Others argue it's just a statistical fluke, a 1 in a million chance that randomness painted onto the sky. But here's the catch: even if it's a fluke, the sheer scale of the void forces us to ask, how many flukes can our models handle before they break? Perhaps the most unsettling idea is this: the Eridanus Supervoid might be a crack in our understanding of dark energy, or even the nature of space itself. If empty patches can warp temperature so dramatically, what else have we underestimated? Sometimes the universe's quietest corners shout the loudest questions. And this one, it's practically screaming. Galaxies are supposed to follow a recipe: stars, gas, and an invisible glue called dark matter holding it all together. But the universe loves breaking its own rules. Enter NGC 1052 DF2, a galactic rebel that tossed out the playbook. This wispy, ghostly galaxy floats through space with almost no dark matter at all, a cosmic contradiction that left astronomers rubbing their eyes in disbelief. Dark matter isn't just some minor ingredient. It's the hidden scaffolding of the universe, outweighing visible matter 5-1. Without its gravitational pull, ordinary galaxies would spin themselves apart like unmoored merry-go-rounds. Yet DF2 dances on, its stars moving lazily as if gravity itself forgot to show up. The discovery was so shocking, researchers triple-checked their data, convinced they'd made a mistake. But the numbers held. This galaxy defies the cosmos's most fundamental law. So how did it form? One theory suggests a violent past. Perhaps a cataclysmic collision stripped away its dark matter long ago, leaving behind a skeleton of stars. Others wonder if DF2 is a rare misfire, a galaxy born in an unusual pocket where dark matter never gathered, but the most tantalizing possibility. It's proof that dark matter and galaxies aren't as inseparable as we thought. Maybe galaxies can assemble without it, rewriting the story of how cosmic structures take shape. Whatever the answer, DF2 is more than an oddity. It's a cosmic riddle scribbled in starlight, forcing us to ask, if one galaxy can exist without dark matter, what else have we gotten wrong? Sometimes the universe's greatest lessons come from the things that shouldn't be there, and this ghostly galaxy, it's holding up a mirror to everything we thought we knew. Out in the cosmic darkness, something is sending shockwaves through space, and we almost missed them. Fast radio bursts, or FRB, are among the universe's most fleeting and explosive mysteries. These bursts pack more energy than the sun emits in months into mere milliseconds, vanishing before we can even blink. The first one was discovered in 2007, buried in old telescope data, a blip so brief, researchers initially dismissed it as equipment glitch. But then more appeared, each one a scream of radio waves from galaxies billions of light years away. What's fascinating isn't just their power, but their unpredictability. Some FRBs fire once and never repeat like cosmic firecrackers. Others, like FRB 1211-2, pulse on a loop, flashing like a lighthouse across the void. This split behavior has scientists chasing multiple explanations. Could they be the death throes of neutron stars collapsing into black holes? Or perhaps Magneta's ultramagnetic stellar corpses, snapping under pressure, sending shockwaves rippling through space? Then there's the wild card. Some bursts show patterns too precise to ignore, sparking debates about artificial origins. Imagine a civilization harnessing the energy of stars to power interstellar beacons, or advanced propulsion systems tearing through space-time. It's a long shot, but when the universe throws us a curveball, every possibility deserves a glance. But here's the real intrigue. FRBs might be more than just cosmic fireworks. Their signals get distorted as they travel, offering a way to weigh the invisible matter they pass through, like cosmic X-rays revealing the skeleton of the universe. Each burst is a message, a clue, and a challenge, because for every one we detect, thousands likely slip by unnoticed. The cosmos is whispering in a language we're just beginning to decode, and FRBs. They're its most cryptic syllables yet. In October 2017, astronomers spotted an intruder racing through our solar system, a visitor from another star. Named Oumuamua, Hawaiian for scout, this bizarre object wasn't just passing through. It was breaking all the rules, tumbling like a cosmic cigar, 10 times longer than it was wide. It defied every shape we'd ever seen in nature. But the real shock came when it started speeding up on its way out. Comets accelerate like this all the time, when sunlight vaporizes their ice, creating jets of gas that push them along. But Oumuamua left no visible tail, no dusty puff of outgassing, nothing. So what gave it that extra kick? Some scientists proposed hidden vents spewing invisible hydrogen gas. Others pointed to solar radiation pressure, a weak force that shouldn't budge something so massive. Then came the boldest idea of all. Harvard astrophysicist Avi Loeb suggested it might be artificial, a solar sail or derelict probe from an alien civilization. Wild maybe, but consider this. Oumuamua's shape alone is statistically unlikely. Most natural space rocks are lumpy, not needle-like, and its brightness 10 times shinier than any known asteroid, as if polished by something or someone. The real frustration, we only had weeks to study it before it vanished into interstellar darkness. No follow-up, no second glance. Was Oumuamua just a weirdly shaped comet or something far stranger? The answer might be lost forever, but its legacy endures, a cosmic postcard we barely deciphered before it slipped away. And it leaves us with a haunting question. If interstellar visitors drop by this often, how many have we missed and how many are still out there? For all our grand cosmic maps and towering telescopes, there's an unsettling truth: we're barely seeing half the picture. Imagine building a house by only studying the windows while ignoring the walls holding them up. That's essentially what we've been doing with the universe, because dark matter, the invisible skeleton shaping everything, refuses to show itself. We know it's there. Galaxies spin too fast to stay intact without some hidden mass gluing them together. Clusters of galaxies bend light like magnifying glasses, far more than visible matter should allow. Even the cosmos's large-scale structure, that sprawling web of filaments and voids, wouldn't exist without dark matter's gravitational pull. Yet after decades of searching, we've never caught a single particle of it. So what is this elusive stuff? The leading theory points to WIMP, weakly interacting massive particles, hypothetical heavy specks that barely touch ordinary matter except through gravity. Underground labs hunt for them in vats of ultra-pure liquid, waiting for a rare collision. But so far, silence. Another candidate, actions, are ghostly lightweight particles that might convert into photons in strong magnetic fields. Yet experiments designed to catch them keep coming up empty. Here's where it gets radical. Some physicists argue we're chasing a phantom, that dark matter doesn't exist at all. Instead, maybe gravity itself behaves differently on cosmic scales, a theory called modified Newtonian dynamics, or MN. It's a long shot, but it solves some puzzles dark matter can't, like why certain galaxies seem to defy gravity's expected rules. The stakes couldn't be higher. If dark matter is real, it's a shadow universe woven into ours, waiting to rewrite physics. If it's not, Einstein's gravity, the cornerstone of cosmology, needs an overhaul. Either way, this isn't just about finding missing mass. It's about discovering whether the universe plays by the rules we think it does, or if we've been missing the game entirely. Cosmology has always been a game of precision, measuring the universe's heartbeat to understand its past and future. But right now, that heartbeat is sending mixed signals. Meet the Hubble Tension, a modern cosmic mystery that pits our best measurements against each other in a battle with no easy winner. For decades, we've relied on two trusted methods to clock the universe's expansion. The first uses the cosmic microwave background, that ancient glow from the Big Bang, to calculate how fast space stretched in its infancy. The second observes pulsating stars and exploding supernova in nearby galaxies, tracking their movement like cosmic breadcrumbs. Both approaches are meticulous, both backed by brilliant minds, but they stubbornly refuse to agree. The older universe method suggests a slower expansion rate, while local measurements insist it's faster by about 9%. 9% might sound small, but in cosmology, even a fraction of a percent can unravel entire theories. This discrepancy isn't just a glitch, it's a blinking red light on the dashboard of our understanding. Some propose dark energy, the mysterious force accelerating the universe's expansion, might be changing over time, growing stronger or evolving in ways we haven't predicted. Others wonder if undiscovered particles, ghostly relics from the early cosmos, are tweaking gravity's rules in ways we can't yet model. Then there's the radical possibility. What if our assumptions about the universe's geometry are fundamentally flawed? Could unseen structures or dimensions be warping our measurements? The Hubble tension isn't just a technical hiccup, it's a cosmic invitation to rethink the very framework of reality. Every telescope, every supercomputer simulation brings us closer to an answer. And when we find it, the universe might look a little less familiar and a whole lot more fascinating. The universe has a grocery list problem. It's missing half its ingredients. Not dark matter, not exotic particles, but the very stuff we're made of, ordinary atoms called baryons, planets, stars, even your morning coffee. They all trace back to these fundamental building blocks. Yet when cosmologists tally up all the baryons that should exist based on the Big Bang's recipes, nearly half have gone AWOL. Here's what's bizarre. Supercomputer simulations paint a vivid picture of the cosmic web, a labyrinth of gas filaments connecting galaxies like threads in a spider's silk. These wispy tendrils should be brimming with that missing matter, but they're frustratingly dim. Why? Because the gas is so hot and diffuse, it barely emits light our telescopes can catch. It's like trying to spot steam in a sauna with the lights off. Recent breakthroughs, though, are turning up the heat. Astronomers have begun detecting this phantom matter through its subtle fingerprints, the way it bends background light or absorbs flashes from distant quasars like cosmic sponges. Some of it might even lurk in vast reservoirs around galaxies, too faint to see directly, but the plot thickens. Even these detections don't fully close the gap. Where's the rest? One daring idea suggests some baryons could be hiding in intergalactic voids, stretched so thin they're virtually invisible. Others speculate they've been catapulted out of galaxies entirely by supernova explosions or black hole jets. But the real lesson here isn't just about missing atoms, it's about humility. After centuries of studying the cosmos, we're still piecing together the inventory of normal matter. And if we can't even account for the stuff we understand, imagine what else might be hiding in plain sight. Even the heaviest objects in the universe aren't immune to cosmic eviction notices. Picture a supermassive black hole, an anchor weighing billions of suns, suddenly hurled into the void like a pebble from a slingshot. That's exactly what Hubble witnessed, a monstrous black hole barreling through intergalactic space, dragging a bizarre chain of newborn stars in its wake. This wasn't some delicate drift, it was a full-speed cosmic jailbreak. So how does something that massive get kicked out? The leading theory involves a chaotic galactic merger, two galaxies colliding, their central black holes spiraling closer until they unleash gravitational waves so powerful the recoil flings one black hole clear across the cosmos. Think of it as a cosmic game of pool where the cue ball gets shot off the table. But here's the twist. The black hole isn't traveling alone. As it plows through surrounding gas, the violent compression ignites star formation, leaving a sparkling trail millions of light years long like a runaway truck spraying sparks. Yet some astronomers aren't satisfied with this explanation. Could it be something stranger, perhaps an encounter with a dark matter structure we can't see, or even the tug of a nearby supercluster warping space-time itself? Whatever the cause, this anomaly proves a humbling truth. No object, no matter how colossal, is truly anchored in place. The universe has a way of rearranging furniture on scales we're only beginning to grasp. And sometimes that furniture gets thrown out the window. Most stars flicker like predictable metronomes, but then there's Tabby Star, the cosmic wildcard that refuses to play by the rules. Astronomers first noticed it in 2015, when Kepler Space Telescope data revealed something bizarre. This otherwise ordinary star, officially named KSE 8462852, was dimming erratically, sometimes by a staggering 22%. That's not just unusual, it's impossible by standard stellar physics. Planets, even giant ones, might block 1 or 2% of a star's light, but 22. That's like throwing a beach towel over a lighthouse and expecting it to vanish. Initial theories scrambled to explain the dips. Maybe a colossal swarm of comets, thousands strong, was passing in front of the star, but even that couldn't account for the irregular timing or depth of the dimming. Then came the electrifying and controversial suggestion: alien megastructures, specifically a Dyson swarm hypothetical energy collecting satellites built by an advanced civilization, orbiting in a dense cluster that occasionally blocks the star's glow. The idea sent ripples through the scientific community because while extraordinary claims require extraordinary evidence, Tabby's star was certainly acting extraordinary. Yet as more observations piled up, the plot thickened. The star's light didn't just dip, it faded overall, dimming by 14% over a century. No known natural phenomenon, from comets to interstellar dust, explains both the long-term dimming and the erratic dips. Some researchers now suspect an ongoing cosmic catastrophe, perhaps a recently devoured planet, its debris spiraling into the star in chaotic, uneven waves. The real magic of Tabby's star isn't just the mystery, it's how it forces us to question what we think we know. Every time we've tried to pin it down, it's slipped away, dancing just beyond the edge of our understanding. Whether it's a natural oddity or something more profound, one thing's clear: the universe keeps a few cards up its sleeve, and Tabby's star might be its wildest one yet. Tucked away in the cosmic microwave background, the afterglow of the Big Bang itself, there's a patch so cold, it sends shivers down the spines of cosmologists. Known simply as the CMB cold spot, this eerie region spans nearly 2 billion light-years, registering temperatures significantly lower than its surroundings. It's not just a minor fluctuation. This is a cosmic frostbite, an anomaly so stark it defies conventional explanation. One prevailing theory suggests this cold spot might be a bruise, a relic from a violent collision between our universe and another bubble universe in the multiverse. Imagine two soap bubbles bumping in a vast cosmic sink. Where they touch, space-time could ripple, leaving behind a telltale chill in the CMB. If true, it would be the first tangible hint that our universe isn't alone, that beyond the edges of reality, other worlds might lurk, each with their own laws of physics. But skeptics aren't convinced. They argue it could just be a statistical fluke, a rare but natural dip in the microwave background's otherwise uniform hum. After all, randomness can paint strange patterns if you stare long enough. Yet, the cold spot refuses to fade into obscurity. Detailed studies show it's not just cold, it's surrounded by a peculiar ring of hot gas like a cosmic bullseye. And that's harder to dismiss as mere noise. The debate isn't just academic. If this frigid patch does point to the multiverse, it rewrites our place in the cosmos. Suddenly, the Big Bang isn't a one-time event. It's just one spark in an endless cosmic fireworks display. But until we have irrefutable proof, the cold spot remains a tantalizing enigma, a whisper from the edges of reality that refuses to be ignored. Whether it's a window to other worlds or just a quirk of probability, one thing's certain: the universe's baby picture still holds secrets we've barely begun to decode. The universe left us a receipt from the Big Bang, and the numbers don't add up. Among the lightest elements forged in those first fiery minutes, one is conspicuously absent: lithium. According to our best calculations, the early cosmos should have blasted out 3 times more lithium-7 than we actually detect in ancient stars today. It's as if the universe misplaced an entire ingredient from its primordial recipe book. So where did it all go? One theory points to stellar culprits, aging stars that might have burned up lithium like cosmic furnaces, transmuting it into heavier elements over billions of years. But here's the catch: even the oldest stars, relics from near the dawn of time, show this lithium shortfall. If stars destroyed it, they did so suspiciously fast, leaving no trace of the expected abundance. Another idea takes us deeper into the subatomic realm. Maybe unknown particles, like certain types of dark matter, interacted with lithium in ways that altered its production or survival rates during nucleosynthesis. Or perhaps our models of the Big Bang's nuclear kitchen are missing a key variable, a tweak to the temperatures or densities that would resolve the mismatch. But the most tantalizing possibility, this lithium gap might be a breadcrumb leading to new physics. If the laws governing nuclear reactions operated differently under the extreme conditions of the infant universe, it could rewrite our understanding of cosmic alchemy. Every ancient star we study is a time capsule, and their stubborn lack of lithium whispers that the universe's first moments were far more complex than we've imagined. This isn't just about missing atoms, it's a challenge to the very equations we use to trace the universe's birth. And until we solve it, that discrepancy lingers like a phantom in the data, reminding us that even the simplest elements can hide the deepest secrets. Stars in a galaxy should obey the laws of gravity like clockwork, slowing down as they orbit farther from the center, just like planets in our solar system. But the universe loves throwing curveballs. When astronomers first measured the speeds of stars in spiral galaxies, they found something jaw-dropping. Instead of slowing down, these outer stars raced just as fast as those near the core, as if some unseen hand was giving them an extra push. This mismatch between prediction and reality is the galaxy rotation problem, and it's one of the strongest hints that our cosmic ledger is missing something massive. Enter dark matter, the invisible glue theorists say must be there, adding enough gravity to keep these stars from flying off into the void, but not everyone's convinced. A rebellious faction of physicists argues the problem isn't missing matter, it's our understanding of gravity itself, their alternative modified Newtonian dynamics or MN. This tweak to Einstein's equations suggests gravity behaves differently at galactic scales, eliminating the need for dark matter entirely. Here's where it gets messy. MN predicts galaxy rotations beautifully but stumbles when faced with other evidence, like the way galaxy clusters bend light. Meanwhile, dark matter explains those clusters, yet decades of hunting haven't produced a single direct detection of its particles. So who's right? The answer could redefine physics. If MN wins, gravity isn't universal. If dark matter does, most of the cosmos is made of something we've never touched. Right now, telescopes and particle detectors worldwide are racing for answers, because this isn't just about why stars spin funny. It's about whether the universe is mostly invisible or whether we've been reading its rulebook wrong all along. In the chaotic final act of a star's life, nature usually prefers asymmetry, bursts of gas and dust ejected in all directions, forming messy, unpredictable nebulae. But the Red Rectangle Nebula didn't get the memo. About 2,000 light-years away, this cosmic oddball stands defiantly geometric, its glowing gases arranged in a near-perfect X-shape, like some celestial architect drafted it with a ruler. At its heart lies a dying star, much like our Sun, expelling its outer layers in a final, fiery farewell. Normally, such stellar death throes produce chaotic, bubble-like structures. So why the crisp symmetry here? The leading theory points to a hidden dance partner, a binary companion star whose gravitational pull funnels escaping gas into two opposing cones, creating that striking X when viewed from Earth. It's like squeezing a balloon symmetrically from both ends, forcing the air out in precise jets. But not everyone's convinced this tells the full story. Some researchers suggest magnetic fields, far stronger than expected, might be shaping the nebula's skeleton like invisible wires. Others wonder if the star's own rotation, spinning at just the right speed, carved this structure over millennia. Then there's the nebula's eerie red glow caused by rare carbon molecules that shouldn't survive in such abundance, hinting at chemistry we've yet to untangle. The red rectangle isn't just a pretty cosmic quirk. It's a laboratory for testing how stars die under unusual conditions, offering clues about the hidden forces, gravitational, magnetic, or otherwise, that sculpt the universe's most breathtaking structures. And perhaps the most humbling thought, this isn't some distant galactic spectacle. It's right in our cosmic backyard, reminding us that even the familiar can harbor jaw-dropping surprises. Saturn, the ringed jewel of our solar system, hides one of nature's most precise geometric secrets at its north pole, a perfectly hexagonal storm. This isn't some fleeting cloud formation. This six-sided monster has raged for decades, possibly centuries, its razor-sharp edges defying the chaotic turbulence we expect from planetary weather. How does a storm, of all things, hold such a crisp, unnatural shape? Earth's hurricanes spiral wildly, but Saturn's hexagon locks into its corners like a cosmic stop sign. Laboratory experiments with spinning fluids have recreated similar shapes, hinting that deep beneath those golden clouds, jet streams moving at different speeds might carve out this polygon through sheer atmospheric friction. Yet even the best models can't fully explain why it remains so unnervingly stable, or why nothing like it exists elsewhere in the solar system. Some scientists speculate the hexagon acts like a standing wave, an atmospheric echo trapped around the pole by Saturn's rapid rotation. Others wonder if deeper forces, hidden vortices, or interactions between layers of gas could be reinforcing its structure like an invisible scaffold. But here's the real kicker. While we've seen other polygonal patterns in lab experiments, none last. Saturn's hexagon, on the other hand, endures unbothered by time or the planet's violent storms raging just outside its borders. This isn't just a curiosity, it's a masterclass in how little we truly understand planetary atmospheres, even in our own cosmic backyard. If a six-sided storm can outlast human civilizations without breaking form, what other wonders are hiding in plain sight, waiting for us to look closer? While Venus is often called Earth's twin, its atmosphere behaves like something from another dimension entirely. At the planet's south pole, a nightmare of swirling gases forms a colossal double vortex, a churning, hurricane-like structure with two distinct eyes spinning in perfect sync. Clocking in at roughly the size of Europe, this atmospheric beast completes a full rotation every 2.2 days, defying every expectation of planetary weather. What makes this vortex so baffling isn't just its shape. Similar polar storms exist elsewhere: Saturn's hexagon, Jupiter's polar cyclones, but none twist into this eerie double helix. On Earth, hurricanes dissipate without warm ocean water to fuel them. Yet Venus, with no liquid surface and winds that scream at hurricane speeds higher up, somehow sustains this monstrosity indefinitely. One theory suggests the vortex is a product of Venus's super-rotating atmosphere, where the entire upper atmosphere whips around the planet 60 times faster than its surface. This creates violent shear forces, possibly funneling gases into these unnatural twin spirals. Others suspect the planet's extreme greenhouse effect plays a role, with solar heating and chaotic cloud layers driving the storm like a cosmic heat engine. But here's the real puzzle. Data from missions like Venus Express show the vortex occasionally morphing, sometimes splitting into three lobes, other times squashing into a squall line. It's as if the storm can't decide what shape to take, yet always snaps back to its signature double spiral. Some researchers wonder if hidden topography, mountain ranges or ancient volcanoes could be redirecting winds from below, like invisible hands sculpting the tempest. Whatever the answer, this isn't just about Venus. It's a case study in how atmospheres behave under extreme conditions, knowledge that might someday unlock secrets about exoplanets with equally alien skies. And for now, that restless vortex keeps spinning, a cryptic reminder that even our nearest planetary neighbor refuses to play by the rules. At first glance, Mars seems like a frozen, lifeless desert, until you catch a whiff of its atmosphere. Or rather, what shouldn't be there, methane. This simple gas, a mere 4 hydrogen atoms clinging to a carbon, might not sound thrilling. But on Earth, methane is a flashing neon sign of life, belched by cows, bubbling up from swamps, even leaking from landfills. So when NASA Curiosity rover started sniffing out sporadic methane spikes in Gale Crater, the scientific community held its breath. These weren't steady leaks. They came in unpredictable bursts, vanishing almost as quickly as they appeared. The plot thickens. Mars lacks the obvious methane factories we see on Earth. No termites, no melting permafrost, no belching livestock. So where's this gas coming from? One possibility is geology. Certain rocks, when exposed to water and heat, can produce methane through chemical reactions. The problem, Mars's sporadic spikes don't match the steady output we'd expect from such processes. Another theory suggests underground reservoirs, trapped beneath ice or salt deposits, might occasionally crack open and vent their contents like a cosmic pressure cooker. Enter Perseverance, NASA's latest rover, armed with instruments designed to dissect this mystery with surgical precision. Early data shows methane levels fluctuating even within a single Martian day, wild swings that defy easy explanation. Some researchers speculate that ultraviolet light could be breaking down organic molecules scattered across the surface, creating ephemeral methane puffs. Others dare to whisper the L-word: life. Microbes buried deep beneath the sterile surface might be churning out methane in isolated pockets, their faint metabolic signatures slipping through cracks in the rusty soil. Here's the twist: the European Space Agency's Trace gas orbiter, circling Mars overhead, has largely failed to confirm Curiosity's methane detections. Is the rover sitting atop a local hotspot, or is the methane vanishing before it reaches orbit, destroyed by some unknown atmospheric process? The disagreement isn't just frustrating, it's a tantalizing clue. Because if methane can appear and disappear this unpredictably, Mars might be hiding entire chapters of its story in plain sight. For now, the mystery lingers like a phantom scent, taunting us with possibilities. Whether the answer lies in ancient rocks, hidden aquifers, or something far more extraordinary, one thing's certain: Mars still has secrets, and they're written in a language of gas we're only beginning to decode. On a quiet summer morning in 1908, something tore through Earth's atmosphere with the force of 2,000 Hiroshima bombs. Witnesses in Siberia described a fireball brighter than the sun, followed by shockwaves that flattened 80 million trees across 800 square miles. Yet when scientists reached the remote Tunguska region decades later, they found no crater, no fragments, nothing but a radial scar of destruction. The leading suspect, a comet or asteroid exploding midair, vaporizing before impact. But here's the catch: such events should leave traces, metallic dust, chemical residues, and Tunguska's soil stubbornly refused to cough up conclusive proof. Some researchers argue it was a stony asteroid, its debris scattered too finely to detect. Others propose an icy comet nucleus, bursting apart in a plume of superheated gas with no solid remnants. Then there are the wild cards. Could it have been a chunk of antimatter, annihilating itself in a flash of energy, or a microscopic black hole passing through Earth like a bullet through fog? Even Nikola Tesla speculated his wireless power experiments might have accidentally triggered the blast, though most dismiss that as pure fantasy. What makes Tunguska truly unsettling isn't just the mystery, it's the reminder that our planet sails through a cosmic shooting gallery. An event like this over a major city today would devastate entire nations. Yet for all our telescopes and early warning systems, we're still piecing together what happened that morning over Siberia. Whether it was a rogue space rock or something more exotic, one lesson echoes through the century. The universe doesn't need permission to throw us a curveball. And next time, we might not be so lucky. Look up on a clear, moonless night just before dawn or after dusk, and you might spot an eerie, cone-shaped glow stretching from the horizon, an ethereal pillar of light often mistaken for twilight. This is the zodiacal light, sunlight bouncing off countless specks of cosmic dust drifting between the planets. But here's what astronomers can't explain: there's too much of it. For centuries, we assumed this dust was just debris left over from asteroid collisions and comet tails. Yet modern calculations reveal a staggering mismatch. The amount of dust we see should have been blown out of the solar system by solar radiation long ago. Like sand slipping through an hourglass, this interplanetary grit should have dwindled to nearly nothing over billions of years, but the glow persists bright as ever. So where's the hidden reservoir refilling it? One theory points to Jupiter's gravitational pull, nudging icy bodies from the outer solar system inward where they crumble into fresh dust. Others suspect a stealthy population of asteroids, too dark or distant for our telescopes to spot, grinding themselves down over time. But the most tantalizing possibility involves interstellar visitors, rogue comets, or even dust clouds from beyond our solar system, seeding our neighborhood with fresh material as they pass through. The zodiacal light isn't just a pretty sky phenomenon. It's a cosmic ledger recording the invisible traffic of our solar system. Every photon we catch in that glow carries hints about the forces quietly reshaping our celestial backyard. And until we solve this paradox, one thing's clear: even the emptiest corners of space are busier than they seem. The sun should follow a simple rule: the farther you get from its fiery core, the cooler things become. Yet standing just above its surface, past the relatively cool 6,000-degree photosphere, is an inferno that defies logic. Here, the solar corona rages at millions of degrees, hotter than the sun's own surface beneath it. It's like walking away from a bonfire only to step into a blast furnace. So what's superheating this cosmic halo? One clue lies in the sun's tangled magnetic fields. Like invisible whips, these fields crackle with energy, channeling waves that ripple through the corona. Some scientists believe these magnetic waves, dubbed Alfvén waves, carry enough punch to transfer heat outward, like a tremor traveling along a vibrating wire. But there's a catch. While these waves can explain some of the heat, the math still leaves gaps hotter than the corona itself. Enter nanoflares, tiny, relentless explosions speckling the sun's atmosphere. Individually, they're barely a blip, but together they might form a constant drizzle of energy. Picture a popcorn machine where each kernel pops too quietly to hear, but collectively, the bursts keep the entire room warm. Some spacecraft data supports this, showing the corona flickering with micro-explosions that could add up to staggering temperatures. Yet even these theories can't fully account for the corona's extreme heat. Some researchers suspect larger, undiscovered flares might be at play, while others wonder if particle acceleration, charged particles surfing magnetic fields at near light speed, could be pumping extra energy into the mix. Every solar eclipse, when the moon unveils the corona's shimmering tendrils, scientists get another chance to decode its secrets. One thing's certain: until we crack this puzzle, predicting solar storms, which boil up from this very layer, will remain an imperfect science. And with those storms capable of frying satellites and knocking out power grids, the corona isn't just a mystery. It's a ticking clock. Gaze up at the moon tonight, and you're seeing the same craters, the same dark plains that ancient astronomers sketched millennia ago. Not because they never change, but because the moon is hiding half itself from us. Like a cosmic dancer spinning just fast enough to keep its back turned, our lunar companion stubbornly shows only one face to Earth, a phenomenon called tidal locking. But here's the twist: this gravitational tango shouldn't be perfect. other moons in the solar system wobble slightly, revealing glimpses of their far sides. So why is ours so impeccably synchronized? The secret lies in a slow-motion tug-of-war between Earth and the Moon. Billions of years ago, the Moon spun freely, its rotation gradually braked by Earth's gravity pulling unevenly on its slightly oblong shape. Over eons, this created friction, like an invisible hand pressing on a spinning top, until the Moon's rotation matched its orbit, locking one face permanently toward us. But what's fascinating isn't just the locking, it's the timing. Most moons take much longer to achieve this balance if they ever do. Our moon, however, seems to have locked in place suspiciously fast. Some scientists suspect a cataclysmic infancy might explain it. If the moon formed from debris after a Mars-sized object smashed into early Earth, its initial orbit could have been far closer, accelerating the tidal locking process. Others point to the moon's unusual distribution of mass. Its crust is thicker on the far side, as if something piled extra material there like a cosmic counterweight, helping Earth's gravity catch it sooner. But the mystery doesn't end there. Even now, the moon is drifting away about 1.5 inches farther each year, meaning Earth's grip weakens over time. In the distant future, its lock could loosen, offering distant descendants a glimpse of the long-hidden far side. Until then, that silent, cratered face remains a relic of celestial mechanics, a testament to the unseen forces that sculpted our cosmic neighborhood. And perhaps a reminder, sometimes the most familiar things are the ones keeping the biggest secrets. Scattered across the rusty plains of Mars like marbles dropped by some absent giant, the so-called blueberries caught scientists completely off guard. When NASA Opportunity rover rolled onto the scene in 2004, its cameras revealed a landscape peppered with these tiny, iron-rich spherules perfectly round, no larger than BB pellets and impossibly uniform. At first glance, they might seem like a geological curiosity, but these unassuming orbs hold secrets that could rewrite Mars's watery past. The leading theory points to ancient groundwater. On Earth, similar concretions form when mineral-rich water percolates through porous rock, gradually depositing layers of iron oxide like microscopic tree rings. If Mars's blueberries followed the same recipe, they'd be smoking gun evidence of a planet once awash with liquid, a place where life could have gained a foothold. Yet not everyone's convinced. Some researchers argue volcanic eruptions might have sprayed molten droplets into the air, solidifying into these spherical time capsules as they rained down. Then there's the wild card. Could they be remnants of meteorite impacts fused into tiny beads by the heat of violent collisions? Each hypothesis paints a different portrait of Mars's history. Waterborne minerals suggest a hospitable past. Volcanic origins hint at a more turbulent, fiery world, and impact remnants. They'd underscore just how relentlessly space pummels the red planet. What makes these blueberries especially tantalizing is their stubbornness. Unlike other Martian mysteries, they're tangible little globes we could one day hold in our hands, each layer a page in an unread planetary diary. For now, they sit quietly in the dust, patient as fossils, waiting for us to decode their story. Whether they're droplets from a vanished ocean or cinders from an erupting sky, one thing's certain: sometimes the smallest things carry the weightiest clues. Of all the cosmic coincidences, this one might take the prize. Picture two worlds, one a scorching hellscape boiling under a thick, toxic atmosphere, the other a frozen outpost orbiting the solar system's most distant giant. Venus and Neptune's moon, Triton, couldn't be more different in location, yet their surface temperatures hover eerily close to the same frigid -390 degrees Fahrenheit. How does a moon 4 times farther from the Sun than Pluto manage to match the oven-like conditions of our so-called sister planet? The answer lies in 2 wildly different mechanisms conspiring to reach the same result. Venus, wrapped in clouds of sulfuric acid and carbon dioxide 90 times thicker than Earth's air, is the poster child for the runaway greenhouse effect. Sunlight slams into its atmosphere, gets trapped, and turns the surface into a pressure cooker hot enough to melt lead. Meanwhile, tiny Triton, a captured Kuiper belt object now orbiting Neptune, relies on an entirely different trick: geysers. Vast plumes of nitrogen gas erupt from beneath its icy crust, carrying dark dust that coats its surface. That sooty blanket absorbs just enough of the sun's feeble light to generate a whisper of warmth, balancing its temperature in a way that defies logic. Here's where it gets stranger. Triton shouldn't even have this activity. At its distance from the sun, most worlds are frozen solid, their interiors long dead. Yet something, perhaps tidal flexing from Neptune's gravity or residual heat from its violent capture, keeps Triton's engine churning. Venus, on the other hand, is a cautionary tale of what happens when a planet loses its ability to regulate heat. Two roads, one temperature, one paved by relentless atmospheric pressure, the other by cryovolcanic sleight of hand. This cosmic mirror isn't just a fun trivia fact. It's a lesson in how wildly different processes can converge on the same outcome. Whether it's the crushing weight of an atmosphere gone rogue or the delicate dance of ice and gas at the edge of the solar system, nature finds ways to surprise us. And sometimes the most unexpected parallels reveal just how creative the universe can be when bending its own rules. Imagine a storm where the raindrops aren't water, they're diamonds. On distant ice giants like Uranus and Neptune, this dazzling deluge isn't science fiction, it's science fact. Deep beneath their swirling blue atmospheres, crushing pressures and scorching temperatures transform carbon into glittering crystals that fall like cosmic hail, sinking toward the planet's cores. This isn't just a curious weather event, it's a window into the bizarre physics of alien worlds. Here's how it works. These gas giants are rich in methane, a molecule built around a single carbon atom. As you descend through their layers, pressures mount to millions of times Earth's surface, while temperatures soar to thousands of degrees. Under these extremes, methane shatters, breaking apart into hydrogen which floats away and carbon, forced into a crystalline structure. The result, diamonds, forged not in the slow geologic furnace of Earth's mantle, but in the chaotic depths of a planetary maelstrom. But the real marvel isn't just their formation, it's their journey. Scientists suspect these diamonds don't just sit still. They grow, some reaching the size of icebergs before plunging downward through slushy layers of hydrogen and helium, creating friction that may generate heat as they go. Some models even suggest these sinking gems could trigger electrical currents, subtly shaping the planet's magnetic fields. The implications stretch far beyond our solar system. Ice giants like these are common in the cosmos, and where there's carbon and crushing pressure, diamond rain might be the rule rather than the exception. In fact, some exoplanets drenched in carbon-rich atmospheres could experience diamond storms so dense they form vast subsurface layers of solid gemstone. Yet for all its allure, this phenomenon remains just out of reach. No probe has ever plunged deep enough into an ice giant to witness it firsthand. Until we do, diamond rain remains a tantalizing blend of theory and imagination, a reminder that the universe's most extraordinary treasures might not be found in its stars, but in the hidden storms raging beneath its clouds. Somewhere in the vast ocean of space, invisible bullets are raining down on Earth, cosmic rays packing more punch than anything our largest particle accelerators can produce. These aren't your everyday space particles. We're talking about ultra-high-energy cosmic rays, subatomic projectiles moving at nearly the speed of light with energy so extreme they defy explanation. The strangest part, they're not arriving randomly. Instead, they seem to cluster in mysterious hotspots scattered across the sky, yet when astronomers point their telescopes at these regions, they find nothing. No supernovas, no black holes, no obvious cosmic accelerators capable of launching particles with such ferocity. The numbers alone are mind-bending. A single one of these particles can carry the energy of a well-thrown baseball, all squeezed into a proton smaller than an atom. To reach these velocities, they'd need to be hurled by something unimaginably powerful, like a supermassive black hole's jet or a cataclysmic galactic collision. Yet when we trace their paths backward, the trails often lead to empty voids between galaxies. It's as if the universe is flinging these atomic bullets at us with an invisible slingshot. One theory points to active galactic nuclei supermassive black holes devouring matter and spewing out particle beams. But the closest candidates are millions of light years away, and the math doesn't quite add up. Others suggest exotic phenomena like defects in the fabric of space-time left over from the Big Bang, or decaying super-heavy dark matter particles annihilating in flashes of energy. Then there's the wild card. What if these rays are the fingerprints of physics we've yet to discover, a cosmic particle accelerator operating on principles beyond our current models? For now, observatories like the Pierre Auger Array in Argentina stand guard, capturing these rare particles as they slam into Earth's atmosphere. Each detection is a clue, a breadcrumb pointing back to an unseen source lurking in the darkness. Until we crack this enigma, one thing's certain: there's a hidden engine out there revving at energies we can't yet comprehend, and it's firing cosmic cannonballs straight at us. Galaxies come in all shapes and sizes, spirals with sweeping arms, ellipticals like cosmic footballs, even oddball irregulars. But then there's Hoag's object, a celestial bullseye so perfect it looks almost artificial. Floating in the void some 600 million light-years away, this stunning ring galaxy presents astronomers with a cosmic riddle. How does something so precise, so engineered-looking, exist without any obvious explanation? At its heart lies a golden yellow core of ancient stars, a familiar sight not unlike the center of a spiral galaxy. But instead of arms winding outward, Hoag's object is encircled by a near-flawless ring of younger, blue stars separated by a vast, empty gap. It's as if someone carved out a galactic donut, leaving two distinct structures forever orbiting each other without touching. So how did this happen? Normally, rings like these form after a galactic collision, one galaxy plowing through another, sending shockwaves of gas and dust rippling outward to birth new stars. But Hoag's object shows no signs of such violence. No twisted debris, no remnants of a cosmic crash, just pristine symmetry hanging in space like a work of art. One theory suggests a slow-motion merger billions of years ago, where a smaller galaxy passed through Hoag's center, leaving its outer regions unscathed while triggering star formation in a perfect circle. Others propose a rare instability in the galaxy's own disk caused it to ripple outward, creating that ethereal ring without any outside help. Then there's the wild card. Could this be a glimpse of an entirely unknown galactic evolution process, one that doesn't rely on collisions at all? What makes Hoag's object truly mesmerizing isn't just its mystery, it's the sheer audacity of its perfection. In a universe that usually favors chaos, here's a structure that defies expectations with quiet elegance. And perhaps that's the real lesson. Sometimes the universe doesn't need a dramatic explosion to create something extraordinary. Sometimes it just needs time, patience, and a set of rules we're still learning to read. Every second, galaxies drift farther apart, not just coasting on the momentum of the Big Bang, but accelerating as if some unseen hand keeps pressing the cosmic gas pedal. This isn't just expansion, it's a runaway universe, and the culprit is one of the greatest mysteries in science: dark energy. Imagine the cosmos as a loaf of raisin bread baking in the oven. As the dough rises, the raisin's galaxies move apart, but what if the loaf suddenly started expanding faster? as if the oven itself were stretching the dough from within. That's the eerie reality we're facing. In the late 1990s, astronomers studying distant supernova made a jaw-dropping discovery. The universe's expansion isn't slowing down due to gravity, as everyone expected. It's speeding up, and the only explanation, a mysterious, repulsive force, dark energy, making up a staggering 68% of everything in existence. Here's where it gets baffling. Dark energy isn't some exotic particle or shadowy matter. It behaves like a property of space itself, growing stronger as the universe expands, as if empty vacuum somehow generates more push the bigger it gets. Einstein once dreamed up a similar concept, the cosmological constant, but even he dismissed it as his greatest blunder. Now it might be the key to everything. Yet alternatives lurk in the shadows. Could dark energy be proof of extra dimensions leaking gravity into our universe, or a sign that Einstein's theory of gravity breaks down on cosmic scales? Some theorists even suggest the acceleration isn't real, just an illusion caused by our galaxy floating in a vast cosmic void, distorting our view like a funhouse mirror. The stakes couldn't be higher. If dark energy keeps growing, it could tear apart galaxies, then atoms, in a distant but inevitable big rip. Or maybe it'll fade away, letting gravity reclaim control. For now, telescopes like Euclid and the Vera Rubin Observatory are racing to map its influence across billions of light years. Because this isn't just about why the universe flies apart. It's about whether space itself holds secrets we've barely begun to fathom. And that changes everything. For centuries, black holes existed only in the fever dreams of mathematicians, a cosmic abstraction, scribbled in the margins of Einstein's equations. Then, in April 2019, the unseeable became undeniable. A global network of telescopes working in perfect sync unveiled humanity's first photograph of a black hole's shadow, a fiery ring of light circling the abyss at the heart of galaxy M87. That glowing silhouette wasn't just confirmation of Einstein's century-old predictions. It was a key turning the lock on an entirely new era of cosmic discovery. The image itself is deceptively simple. A lopsided halo of superheated gas swirling at nearly the speed of light around a darkness so profound not even photons escape. That asymmetry, though, hides violent secrets. The brighter lower edge, that's material moving toward us, boosted by relativistic effects, like cosmic headlights flaring in our direction. The fainter top, gas hurtling away, its light stretched thin by the black hole's gravitational grip. But here's what no equation could have prepared us for: the sheer chaos of the accretion disk. Instead of a neat, flat plane like Saturn's rings, the plasma churns in turbulent filaments, twisted by magnetic fields into structures that defy our models. And then there are the jets. Not all black holes launch them, but M87's beast hurls twin beams of matter and energy half a galaxy long. The photo hints at their origin, a whirling vortex of magnetic fields near the event horizon, acting like a cosmic particle slingshot. Yet how exactly these jets form, or why some black holes erupt while others stay eerily quiet, remains one of astrophysics' fiercest debates. Some theorists argue the black hole's spin acts like a dynamo, while others suspect instabilities in the disk itself fling material outward. The real revelation, though, is how much we don't see. That shadow is larger than predicted, a clue the black hole might be spinning slower than expected, or perhaps gorging on more gas than we'd thought. Every pixel in that image is a question waiting to be asked, because this isn't the end of black hole exploration. It's the first grainy frame of a cosmic film we're only beginning to watch. And if history's any guide, the next reel will rewrite the script entirely. If black holes are the universe's ultimate vacuum, swallowing everything in their path, then white holes might be their cosmic opposites, mythical fountains of matter and energy, violently spewing out what black holes suck in. These hypothetical anomalies aren't just science fiction. They emerge from the same equations that predicted black holes long before we saw one. Yet, unlike their dark counterparts, which we've now photographed, white holes remain purely theoretical, existing only in the realm of math and imagination. At their core, white holes are essentially black holes running backward in time. Imagine hitting rewind on a black hole's existence instead of pulling matter inward past the point of no return. A white hole would endlessly repel it, blasting particles and radiation outward with unstoppable force. Nothing could enter, just as nothing escapes a black hole. The concept solves a thorny problem in general relativity. If black holes exist, the math demands that white holes should too. But the universe isn't obligated to indulge our equations. Some theorists suggest white holes could explain mysterious cosmic explosions, like gamma-ray bursts, flashes of energy so intense they outshine entire galaxies for moments. Others take it further, proposing that the Big Bang itself might have been the ultimate white hole event, a singularity erupting into the universe we know. There's even a wilder idea that black holes at the end of their lifespan might transform into white holes, turning their swallowed matter into a new cosmic outburst. Of course, the biggest hurdle is proof. If white holes exist, they'd likely be incredibly unstable, collapsing almost instantly under their own violent output. That makes them nearly impossible to observe, assuming they're real at all. Yet the very possibility challenges our understanding of time, causality, and the fate of what falls into a black hole. Do white holes lurk in the distant cosmos, flickering in and out of existence? Or are they simply mathematical phantoms, elegant ideas that reality never bothered to build? For now, they remain one of the universe's greatest what-ifs, teasing us with the thought that some doors might only open one way. What if everything you know, your memories, your senses, even the screen you're watching right now, isn't real? Not in the way we think, at least. Welcome to the Boltzmann brain paradox, a thought experiment so unnerving. It forces us to question whether the universe itself might be playing an elaborate trick on us. The idea starts with a simple but staggering premise. Given enough time, even the most improbable events become inevitable. In an infinite universe, random quantum fluctuations could, by sheer chance, assemble a fully formed, self-aware consciousness, complete with fabricated memories of an entire life out of pure chaos. And then, just as suddenly, it could dissolve back into the void. These hypothetical beings are called Boltzmann brains, named after the physicist who first grappled with the implications of cosmic randomness. Here's where it gets unsettling. Statistically speaking, in an eternal universe, these freak accidents of consciousness would vastly outnumber real, biologically evolved minds like ours. So how do we know we're not just momentary sparks in the dark? The paradox forces us to confront whether we're a foundational part of a stable, ordered cosmos, or statistical anomalies doomed to blink out as quickly as we appeared. Some physicists dismiss Boltzmann brains as a reductio ad absurdum, a sign that our theories about the universe's infiniteness might need tweaking. Others lean into the mystery, suggesting that if reality is this fragile, it might point to deeper truths about quantum mechanics or even simulation theory. But the most fascinating takeaway isn't about answers, it's about the question itself. This paradox doesn't just blur the line between physics and philosophy, it erases it. Whether we're Boltzmann brains or not, the mere possibility rattles our assumptions about existence, memory, and the nature of reality. And in a strange way, that uncertainty might be the most real thing of all. After all, if we can doubt our own place in the cosmos, maybe that doubt is the one thing we can truly trust. After this whirlwind tour of cosmic enigmas, one truth emerges crystal clear. the universe thrives on defying expectations. From mind-bending black holes to ghostly voids that stretch beyond comprehension, these 40 anomalies aren't just curiosities, they're invitations. Each one whispers that our current laws of physics are merely rough sketches, waiting for the next visionary to fill in the gaps. Think about it. Every scientific revolution began with an anomaly. Galileo's telescope revealing moons around Jupiter, Einstein pondering a beam of light while riding a streetcar. Today, we're surrounded by similar cosmic breadcrumbs, clues that could lead to breakthroughs rewriting textbooks. That flickering star, it might hold the key to dark energy. That radio signal from deep space, a blueprint for new quantum theories. Here's the beautiful part, you don't need a lab coat to contribute. Some of the most profound discoveries started with amateur astronomers, backyard observers, or simply people who refused to stop asking, why? The universe doesn't care about credentials, it rewards curiosity. So whether you're gazing through a telescope or scrolling through space photos, remember, you're witnessing the greatest unsolved mysteries unfold in real time. Before you go, drop a comment below which anomaly left you utterly spellbound. Was it the diamond rains of Neptune, or perhaps the great attractor pulling us toward the unknown? Don't forget to like and subscribe if you've enjoyed this cosmic journey. Hit that notification bell so you never miss our next dive into the universe's deepest secrets. Until then, keep chasing those mysteries, because the next Einstein might just be watching this right now, and who knows, that could be you.